Okay, to solve this problem using Cramer's rule, we need to find three determinants first. The first one we'll find is d. D is what we get by just taking the coefficients out of the left side of this linear system. So 1x, so there's a 1. 3x, so there's a 3. That's the x column. Then you've got negative 3 in the y column and a 4 in the y column. So computing this determinant, we have 1 times 4 is 4. And let me remind you, it's 1 times 4, and then minus the product of the other diagonals. 3 times negative 3 is negative 9. So we're subtracting a negative 9, which is really adding 9. So d is equal to 4 plus 9, which is 13. So there's the first of the three determinants we need to solve in order to solve this, this linear system. So we next have to find, say, d sub x, which is another determinant, which is the same. You can think of this as the same determinant as we had before, but with the x column replaced with 4, 1. So we'll have a 4 and a 1 over the x column. The y column is the same as it was, negative 3 and 4. And while we're at it, let's look at what d sub y is. This time we put the 4, 1 from the right side of this linear system over the y column, leaving the x column the same as it was in the original d. So 1, 3 is the x column. So computing these two determinants, this one we have 4 times 4 is 16. And minus 1 times negative 3 is negative 3. So we're subtracting a negative 3, which is really adding 3. So 16 plus 3 is 19. So d sub x is equal to 19. Finally, for d sub y, computing this determinant, we have 1 times 1, which is 1, and minus the other diagonal, 3 times 4, which is 12. So 1 minus 12 is negative 11. So we found these three determinants, and now all we have to do is put together our results. So x, recall, is equal to d sub x divided by d, and y is equal to d sub y divided by d. So the d is both 13, is 13 for both of these. D sub x we discovered was equal to 19, and d sub y we discovered was equal to negative 11. So those are our solutions for x and y. And if we put them together into a xy coordinate pair, our solution is 19 thirteenths, comma, negative 11 thirteenths. So that point is the point of intersection of the two lines of our linear system. So that's the solution to our linear system.